Today we transfer a relational database to MongoDB. Hello and welcome to episode 10 of tcVision Now How. Our starting position is a relational model with a database of products, customers and orders. The goal is integrating logically connected data through subdocuments, the easy access to related information and avoiding redundancy. Our demo environment consists of a zOS 2.1 with DB2 v11, a Linux server with MongoDB, Windows 10 with the tcVision control board and MongoDB Compass. Of course, tcVision is installed and connected. The layout includes various interrelated tables. The suppliers sell products which can be placed in orders. Orders also contain customer data and one or more products. We turn both groups into one document each. The central tcVision repository for storing the metadata and the connection and processing rules are located in the DB2 on the source side. First, we create a new output target. We name it OrderDB. The type is of course MongoDB. And it contains the connection information for MongoDB. Now the metadata is created. We need an input, an output and a replication. DB2 catalog tables are used for creating the structure. We select the right DB2 and choose not to import compression dictionaries. The catalog tables are read and we import the complete schema OrderDB. Our collection should have the same name as the table. When clicking the Finish button, the import process is completed and the objects are created in the tcVision repository. Let's start with the correlation between suppliers and products. We put both tables with input and output on the workspace. Here we see the input table, the output table and the connections between the fields. Now we change the settings of the output objects to turn the products into a subdocument of the suppliers. The relation to the main document is noted for the products. Of course, we also need to specify through which keys the main document can be found. The outputs are now connected. Now we also need the actual transfer tasks. A sender reads the DB2 and sends the data to the respective receiver without any processing. The receiver is located on the open server side, has the input remote, and the output is the target that is specified in the repository for the respective tables. The script here is the direct read script. For big data volumes, an image copy would be used. In this video we start a transfer via a job. The table that is supposed to be transferred is passed as a parameter. It was successful. After the suppliers, the products are transferred as subdocuments. Here's an example. The first supplier only has one product. Now we put together the structure for the orders by using the customer data. Like before, we put all involved tables on the workspace. First the orders. And then the ordered products. The ordered products become subdocuments of the orders, just like the products became subdocuments of the suppliers before. We specify the main document and the key, and the connection is established. For this example, we also want to store the customer data in the orders by using the structure of the input table. The fields and the properties can be mapped to the output with drag and drop. Then the input table with the customers can be removed from the repository. To create an embedded document for the customer data, the name of the document is specified as prefix. This is repeated for all fields that should be moved to the embedded document. Now a lookup is defined that determines the right record for each customer ID. This lookup runs on the PC and accesses the DB2 on the mainframe, so the built-in DRDA driver of tcVision is used. The placeholder is filled with the right field, in this case with the input field to which the line points. This line now transforms the customer ID into the respective name and determines the remaining fields. To use these, we define the usage of other data of the lookup in the next field. For this, we specify the original field and the column number. We repeat this for all remaining fields until they're linked. Now we can use the job from before to transfer the data. We start with the main document, the orders. The data was transferred successfully. There's a new collection of orders in MongoDB. Every order has assigned customer data. The following transfer adds the ordered products. It was successful as well. We refresh the display and can now look at the ordered products. The order number 10,248 has numerous items. The same metadata is now used for the real-time synchronization. Two tasks execute the permanent synchronization: a sender on the mainframe, a receiver on Linux. Here's the boundary between the systems. The sender reads the DB2 log data with the help of the IFI 306 interface. The log data is sent to the Linux server without processing. On the Linux server there's a receiver. which can be seen here. This receiver receives the data from remote, processes it to stage 3, and implements it into the output in the tcVision repository. For testing, we create change data in DB2. We create a new supplier, double all orders, and cancel the tofu from order 10,254. We look at the data beforehand. The tofu is still there for now. In the order number 10,251 we memorize the ordered amounts: 6 times crisp bread and 15 packs of ravioli. The updates are executed and we see the amounts in the statistic. (2,155) updates, the insert for the supplier, and the cancellation. We check the results in MongoDB. (12 times crisp bread and 30 packs of ravioli). The tofu is cancelled, and our new supplier is implemented. What did we just see? With the example of DB2, we showed that data in relational tables can be easily transferred into interrelated documents. Of course, this also works with relational data in vSIM files or with CA Datacom. Hierarchical data as an IMS and DLI is virtually perfect for MongoDB. Other bus data is well suited as well. Comprehensive mapping functions allow creating information for the document structure of MongoDB. Of course, replica sets and shards are supported. tcVision uses the quick and easy data transfer through the official MongoDB C API without any external components. Thank you for your attention.